Okay, this is the thermal conductivity lab. For this experiment, we're going to be testing the thermal conductivity of different materials. We have a Lexane sample, a pine sample, a sheetrock sample, and a masonite sample. These are all building materials that we have, and we want to study them to determine their efficacy in keeping in or releasing heat. So in each one of the chambers that you can see, right, I have a different one of these samples mounted. For all of the samples, we need to record the thickness, since that factors into our equations. And we're going to take this and stick it into our steam chamber. When we do that, we want to make sure that our interface here, we're going to capture all of the water, since we're going to have to measure it later. I took the liberty of pre-weighing these containers, but we would need the weight of those containers, so that way we can measure the weight of the container versus the weight of the water. So we take the weight of the container, then we subtract we subtract that from the weight of the container with the water. Now, this system is in the process of heating up, but what's going to happen is that we're going to take this, we have a block of ice, we're going to use this as our control, one with a flatter bottom. I'll use this as our control, right? And we're going to put that there, and as this begins to melt, we'll collect the ice over a period of time. We'll do the same thing on our control surface once this gets hot, but with the hot water. And what we'll find is that due to the steam chamber, the heat comes in, and we're going to have this surface here be the temperature of boiling water, 100 degrees C. The ice is going to be at 0 degrees C because it will just have begun melting, and we'll be able to capture our fluid flow across. Now we need to wait on the water collection for the lower chamber until this begins to get hot. And the steam should begin to flow in there any moment. Get that nice and warm. Okay, now that our steam chamber has been brought up to a boil, as you can see here, it's going. We have some water flowing out of the side. You can see that on the first-person camera. And so now I'm going to take my ice sample and drop it onto my steam generator. And so you'll find is that almost very rapidly, depending on the sample, because the sample is already, the interface surface is already hot, we're going to begin collecting water that leaks. As a result of this, or not as a result of this, but in order to keep track of how long that we're going to be doing this for, we're going to set a timer. We're going to do this for 10 minutes a sample. And so what we'll do is we'll record the height of the sample, which I already did, but we also want to record the diameter of the sample right before and after as well, so that way we can make determinations about the height or the total surface area change, or surface volume. You can see at the chamber in the back that I've been recording the water that's been coming off of my room temperature sample almost the whole time. Since the last portion of this cut off, while I was waiting for this to heat up, it took about 10 or 15 minutes to do so, so our timer for that's actually about 10 or 15 minutes ahead of this. And so I had a second timer for that, and so I'll be able to do some computation about how long that took over there.